This is the foldable for section 5.5, and what we're looking at today is absolute values with inequalities. So this is section 5.5, and we're looking at absolute value inequalities. And we're going to fold it towards the center like this. And we're going to look at the and statements first. So I don't have you memorize whether it's an and statement or an or statement. We're going to practically do the same things, and our picture will tell us, our graph, if it's a and or an or statement. So let's take a look at the and first. To free your absolute value, we're going to put the -4 on this side. The inequality stays the same. So see how it says less than? It's still going to continue to be less than on this side of the inequality. X is less than and then 4. That is the reason that we did the equal sign like we did, even though it's technically incorrect to do the equal sign that way. I wanted to show you one way that always works, and that's why we did that. What this is saying is that at the -4, so we got to put some numbers on here. And then I'm going to go by twos. So -4, -2, 0, 2, 4, 6. At the -2, we don't really know how to read this part, so we got to fix it. Remember, I want the letter on the left. So we fix it so we can graph it, but we're not changing its value. What I'm saying is that this inequality still has to eat that the x. It's eating the x. So it's got to still eat the x when we change the inequality this way. This is where I was telling you that we flipped the whole thing like a tortilla. We're not changing its value. We're just flipping it over. At the -4, we're going to have an open circle, and it's going to go to the right. And then this other part right here, we have an open circle at the 4, and this one's going to the left. The picture tells us that it's an and statement because it looks like a little weight. All right, then this one over here. We're doing the same thing to free the x from the absolute value bars. We do the negative of the value that's over here. We keep the inequality the same. It says less than or equal to, so this one will be less than or equal to x less than or equal to 4. Okay, so I'm going to put the number line on there, still going by -2. So by 2, -2, -4, -2, 0, 2, 4, 6. So remember, we can't really read this side correctly, so I have you flip this side over and not have x. Since it's eating the x, we got to continue making it eat the x, -4. And that just helps us graph it. So at the -4, we have a closed circle because of this line right here. It's going to go to the right. And then this part right here, we have at the -4 a closed circle as well because of this one right here. And this one's going to the left. And this will be an and statement. The reason that we know is because it makes a little weight. Well, let's take a look inside. We have the absolute value by itself on one side of the inequality. That means that we can have its freedom. We're going to put -4. It says less than, so we're going to write another less than symbol. So these two are the same. X plus 1 is less than 4. I draw light little lines like this just to make sure that you do the steps where you need to do them. We have to subtract 1 to solve for x. So we chose this one on purpose. On this side of the equality, we still have to subtract 1. And then on this side of the inequality, we still have to subtract 1. So I want you to notice what it looks like. It looks like you're subtracting 1 on 3 different parts. And we did the similar thing on the equal sign, and that's why I wanted us to do it. So in the inequality, we're not learning something different. It is the same. Negative 4 minus 1 is negative 5, less than x, less than 4 minus 1 is 3. So for this one, what I'm going to do is go by negatives. So odds. Negative 3, negative 5, negative 3, negative 1. You skip the 0, 1, 3, 5. Because then that would be going by ones and not by negatives. Odds. I'll say this correctly one day. So don't forget, this side is the side we can't read correctly, so we flip the whole thing like a tortilla. It's still eating the x. We have a negative 5 over here. So at the negative 5, we have an open circle that goes to the right. Then this part right here is a positive 3, open circle because there's no line underneath, and it's going to the left. So this would be an and statement because it looks like a little weight. The next one says that m plus 1, so the absolute value has to be less than negative 5. Has to be less than negative 5. Is that possible? It can't be less than negative 5. It has to be positive numbers. So this one has no solution. So don't forget, the answers can be negative, but how we set up this inequality has to be positive. The absolute value, there's no way that that could be negative. All right, the next one. Don't forget that we have to isolate the absolute value before we can set it free. So we have to subtract 1 first. So now we have the absolute value of x minus 2 is less than or equal to 3. Now that we have the absolute value all by itself on one side of the inequality, we can set its freedom. So we're going to put negative 3 on this side, less than or equal to, so we keep the inequality the same. X minus 2 is less than or equal to 3. I make the light little lines to make sure that we do it correctly. We're going to add 2 to both sides. All sides, I should say. And we selected adding 2 so we could get rid of this. We have to do it on the right and on the left. Negative 3 plus 2 is a negative 1, is less than or equal to x, is less than or equal to 5. Because 3 plus 2 is 5. Okay, our scale, I'm going to go by odds again. So negative 5, negative 3, negative 1, 1, 3, 5. Remember, on this one is the one that I can't read correctly, so I flip the whole thing. It looks like it's eating the x, so it'll continue to eat the x. And negative 1, you flip the whole thing. So that means that at negative 1, we have a closed circle, and it's going to the right. At the 5, then, we have a closed circle as well, and it's going to the left. So this would become an and statement because it looks like a little weight. I won't ever ask you on a test or on homework assignment whether it's an and or an or statement. I'm just pointing that out for you so you can understand that better. All right, let's take a look at this one. Is this possible? No. It's saying that the absolute value has to be less than negative 6. It can't be less than negative 6. It could be more than, but not less than. So this is no solution. Okay, so let's take a look at the or statements. For the or statements, we're doing the exact same thing. We have the absolute value by itself. So to liberate it, we're going to do negative 4. The inequality stays the same, so that's greater than x greater than 4. I'm ready to graph, and this time I'm going to go by 2's. So -4, -2, 0, 2, 4, 6. At the -4, I can't really read it correctly, so I'm going to change the order of this one. X is less than -4. So at the -4, I have an open circle because there's no line in the bottom, and it's going to go to the left. So on this side right here, we have an open circle at the 4 because there's no line underneath, and we're going to go to the right. And you can tell that they're going opposite directions. That makes it an OR statement. So like I mentioned before, I'm not going to have you memorize nor tell you whether it's an AND or an OR. The pictures should help you out though. Here we have the absolute value by itself, so we can put the negative is greater than or equal to x greater than or equal to 4. Don't forget to flip this side, so we have x is less than or equal to -4. Let's go ahead and draw the scale. I'm going to go by 2's. -2, -4, -2, 0, 2, 4, 6. It is a closed circle that's going to go to the left at the -4, and then at the +4 we still have a closed circle because of the line underneath, and then it's going to go to the right, making it an OR statement. Let's take a look. Okay, so I got to ask you this question. Am I ready to liberate that absolute value? No, it's got that 3 outside, so we're going to divide by 3 to both sides first. Now I have the absolute value of 2x is greater than 10. Now I can set it free, so we have 10 is greater than 2x is greater than 10. We're going to divide by 2. Remember, I like to make those little lines just so you can do it correctly. Divide by 2, divide by 2. -5 is greater than x greater than 5. So you can choose a different scale than I do. I'm going to still go by odds. So I have -5, -3, -1, 1, 3, 5. I have an open circle at the 5. But please don't forget to change this one so we can read it correctly. X is less than -5. So it's eating the 5. So you want to make it continue eating the 5. And that's going to go to the left. On this side, we have an open circle on the 5 because there's no line underneath the inequality. And it's going to go to the right, making it an OR statement. Okay, let's take a look at the next one. Is it ready to set free? Yes, because the absolute value, it's by itself. So this says that the absolute value has to be bigger than -8. Is that possible? So you might think of -7 and -6, but also 1,000 and infinity are at the positive side of this. So this one is possible. It can be greater than -8. So we're going to go ahead and solve it. We can set it free. That means we will have the inequality here. But this is a -8. So what number do you think goes on this side? It will be the +8. So if this one's a negative and it's possible, then we put the positive over here. So 4x minus 2, we set it free, is greater than the -8. Okay, we draw the little lines. We're going to add 2 to all sides. And we did it on purpose to cancel that out. 8 plus 2 is 10. That's greater than 4x, and that's greater than And then negative 8 plus 2 is a negative 6. We're going to divide by 4 now to cancel that out. So we got to divide by 4 on the opposite sides. That gives you 2.5 is greater than x, and that's greater than, sorry, 1.5, a negative 1.5. On this one, I can go by ones. I'm going to put this one as a negative 2, negative 1, 0, 1, 2, 3. Don't forget that this one needs to be flipped because I can't read it that way. X, and that's now going to be less than 2.5. So we flip the whole thing. So at the positive 2.5, we have an open circle that's going to go to the left. And then at the negative 1, negative 1.5 is over here. We also have an open circle that's going to go to the right. So this actually becomes an and statement instead of an or statement. And that's why I don't have you memorize these things. The picture will tell you. All right, next one. For our next one, we have that this is greater than or equal to 1. So let's talk about this. Is this possible? Can this be greater than 1? Yes. Is it isolated? Yes. So we can set its freedom. Negative 1 is what you put on the opposite side. It's still greater than or equal to 2x plus 3. So greater than or equal to 1. I draw the light lines to make sure that things stay separated. We're going to subtract 3 to all sides to get rid of that. Negative 1 minus 3 is a negative 4. Is greater than or equal to 2x. Is greater than or equal to negative 2. We're going to divide by 2 to get rid of that. So go ahead and put division of 2 to the opposite sides. Negative 4 divided by 2 is 2. Negative 2. That's greater than or equal to. Greater than or equal to negative 1. So in case you have to divide by a negative, do you think you have to change the inequalities? Yes, and you change both of them. So if this happened to be a negative number, you still have to change both of the inequalities. We got our number line. We got to fix this one. That would be x is now less than or equal to negative 2. So we can graph it correctly. We can go by 1. So I'm going to go negative 3, negative 2, negative 1, 0, 1, 2. At the negative 2, it is a closed circle, and it's going to go to the left. At the negative 1, it is a closed circle, and it's going to go to the right. Making this an or statement when they go on opposite sides like this. All right, so let's talk about this again. Can this value be bigger than negative 5? Yes. So that's how we know that we can do this problem. And if it's a negative over here, what do I put on the opposite side? The positive. So I'm going to put 5 is greater than or equal to x minus 7 is greater than or equal to negative 5. I draw the lines. We're going to add 7 to solve for the x. To get rid of that minus 7 with the x. 5 plus 7, 5 plus 7 is 13, no, 12, thanks. Is greater than or equal to x is greater than or equal to a positive 2. Yowzes. We can go by 2's. Start at the 2. 2, 4, 6, 8, 10, 12. We need to fix this one though. We have x is less than or equal to 12 once you flip everything. So at the 12, we have a closed circle that's going to go to the left. At the 2, we have a closed circle that's going to go to the right. So that makes it an and statement.